Hi guys, today I want us to perform a simulation using a mid-surface mesh. As you can see, this one looks like a surface, but basically it is a solid. This is volumetric and this is a displacement. We're going to perform similar analysis, but I'm going to start to model these brackets from scratch for you. Therefore, go to File and open a new assembly. You go to File, New Assembly, select Design, and say OK. We are in assembly environment and we need two parts. Therefore, you can use create, select create here, part, use solid, and yeah, say OK. I'm using inches, that's fine, it's just for demonstration. Say OK. And constraint type, just say default and OK. You see, we have this part. Also, another part, same case, OK. Automatic default. Okay, these are two parts that I want us to model in assembly context. Right click here and select activate the selected model. Now we want to model the first part. Go on the top plane, select extrude, go view normal, then select a center rectangle like that. Dimension here to be 10 by, okay, let me use 100 by 60 like that. Okay, extrude by 5. Yeah, you can fill it by 5 or these corners like that. Fillet corners basically is around corners. Then we need some, let me change this. Okay, let's have some mounting holes. Sketch on this face, normal, then select for construction mode, center rectangle like that. Yeah, use dimension here, use 80 by 40, then a hole here, that, like that, like that, like that. Dimension this to be 10, or let's use 8 to be 8. Okay, then select extrude, remove. Yeah, that is my first part, base. This is the base. Activate my second part here like that. Activate the templates because now we go to the front plane here, onto this plane, sketch onto this front like that. Normal, let's use a center line here like that. Align this point like that. Circle, let's have a circle here like that. Then an arc from this point to this point here. Then let's this to have become tangent. Select these two. Oops. Then select this one here and this, mirror to this line and connect these two using a line. Dimension now. First of all, delete this segment. This one here, delete like that. Okay, so now dimension. This to be 20, this to be 20 or 24, this to be 15, this to be 25. That's fine. Then say okay. then extrude by 5, symmetry like that, and you can round off here by 5 also. Yeah, we have hide the planes and activate your assembly. You can now collapse. These are my two parts. You can assign appearance if you want to differentiate between the base. Basically, you can do that. Let's assign appearance to the base. You go to view, appearance here. Let's have this as our base, select as a body, like that. That's fine. Let's now go back to assembly. Okay, now you can see we have base in this part, and we're going to perform finite element analysis, but we're going to use mid surface mesh. If you go to application here, you select simulate. Now the first thing we can do is, if you go to the refine model and select autogen here, autogen, and create the mesh, you can see the mesh here is solid. Everything is solid, but still you can use what we call a surface mesh. Therefore, let me just close. Do you want to save the mesh? Just say no. If you go to the refine model, we have the shell pair, this one here. You have to select detect shell pairs. Okay, and the shell pairs we want to detect, they should have the same thickness. Remember, we used 5. The thickness of the shell will be 5 here. And what we want to detect, what you want to detect the shell pairs in this assembly. You select assembly. I want to detect if we can get a shell or a surface shell that has thickness of 5 at the start. If you go to the idealization here, you can see we have detected two of them. The first one is on the base, you can get a shell, and the other one is on this part here, you can get a shell. If you go to the review geometry and apply, you can see now this green means shell surface. These are the surfaces we have generated. If you go from the right view, this is the middle surface, this is the bottom surface, and you can see these ones are not touching. We have a gap here. This gap is existing because it generated the mid surface of the solid, such that this here is half the thickness and the bottom side is half the thickness. And it means we need to board, you can see here, boarded interface. We need to board these two. We need to get just one line here. Therefore, I need not to board these ones. I need to weld them. If you go to the weld here um, and select weld, the weld I want to select is, first of all, let me hide this weld between this surface here, that will extend to show this to this surface. Okay, now you can see we have this weld connector. If I go back to review geometry and apply, you can see we have just one line. If you go to the front, this one has extended until it touches this surface here to present the weld. If you go to connections here, weld, you can see this is my weld connector here, and we have defined, you start by the surface that you want to extend. You go to the surface that you want to extend it to. You can see here, add weld type, extend single to single. You are going to extend from this surface to this surface. Because you have extend single to single, extend many to single, or extend single to many. Okay, this applies if you have so many bodies in your analysis, you can do that. Next is, if you go back to home, we need not to assign material to this assembly. we select material assignment. Under the material assignment, you can give a name of the material you want. You can say, maybe I can give it a name like my material. The component, you can select an assembly here. If you want to assign the same material to these two components, for the material, you can select, if you don't have any existing material, you can see, you go to more, you can go to the legacy, and you can select steel. Double click steel, you can see now the steel is here. You select, now you can see the material is here, steel, and say okay. Once you assign a material, you should see this symbol. This symbol say represents or indicates that the parts have been assigned the material. You can see the material here, properties. This one is, if you want to suppress, just suppress here, or if you want to edit, you can, if you have another material maybe for different body, you can also add more material, but for now we're going to use same material for the two parts. Next, I want to fix this edge. For this case, for the displacement here, you don't fix a surface because remember we are using a surface mesh. Instead of selecting surfaces, you select edge. And instead of selecting one by one, if you say intent, because we made these ones, we made these holes using one sketch, you can select individual edge one by one by pressing Ctrl, but select intent and select once. For the 2D, this one is a 2D analysis. You need to fix both translation and rotation like that. You have to fix everything and say okay. Those are the load. Next is we're going to apply a bearing load here. If you select bearing, you can give a name, yeah, but here we want to select what? An edge on this edge. Okay, then we want to apply a load of 500 newtons along the y-axis. You can see now this means the bearing is applying the load along the y-axis. You can see the magnitude means the load is maximum at this point and the minimum at this point, but the bottom side we have nothing because we are lifting. It is a bearing load. You want to see what happens. The bearing load of 500. Say okay. Okay. If I go back to refine model and say autogen and create, you see that now the mesh has been created using mid surface. You can see here. If we go front, just want you to see that it's possible. Yeah, the mesh has just been created on the mid surface, and you can see the elements now are less. Okay, these are the tri 15 quad 30. If you compare with the solid, you could have the surface, this mid surface, mid surface elements, mid surface mesh has less number of elements. Basically, that's what I mean. Therefore, close. Do you want to know? Next, we can go to the home and analysis and studies. We want to do the static analysis. We're going to use a single pass adaptive. Okay, output is everything, leave everything as default, and then say start. They must be removed. Yes, yes. Running. This is the diagnostic one. We can just diagnose here. If you want, you have some errors, definitely can say show. So results, I want to see displacement in terms of let me use millimeters. I want to see deformed scaling by 10. I want to animate using maybe 16. Show. You can see how it behaves. If I don't want to see the elements, just do like that. Yeah, you can, if you go to view format, you go to format, edit, I want to change this color from this to using at least gray, the one I'm used of. Just balance this. If you balance them, you get a gray. Try to balance them like that. Okay, make this better. You can go home, you copy. Then I want to see quantity. I want to see stress, that is von Mises, in terms of megapascals here. Display again, just see the deform, the scaling again. Okay, yeah. This one is displacement. This one is von Mises stress. You can see how it looks like, and this one is a displacement. That's how you can carry out a quick FEA for the bearing load in Creo parametric.